that the power to vote for a country is an important part of the democratic country like India. In fact, all the young people who have crossed the age of 18 have the power to vote, but unfortunately many of us do not vote for various reasons. In fact, in 2019 elections, when this campaign was launched to create awareness among young students to vote, the total percentage of voting was only 67.19%. That means still in this country about 32% of the votes, people do not vote. But young people like you should definitely vote for the various reasons. First, because it is your right to vote. Secondly, it is an opportunity for you to make a change. If you want to change, you can make a change. And then, sometimes, recently they have introduced something called as nota. That means if you don't like anybody, that also you can vote. But you should definitely vote. If you don't like any candidate, still you can vote the nota button. And you know that now the Lok Sabha elections are going to come. So your role is very decisive because you are the future stakeholders. Just now the Prime Minister said that you are the torch bearers of this country for the next 30-40 years. So you should play a very important role in the development of this country. And in fact, you know that you need to first register yourself in the election roll. So online you can do it very easy now. So you will be issued a voter ID card. That is a very important card that will serve as an ID card for you for many purposes. And also, you have to vote on the electronic voting machines. You will know that, it's very interesting that the first time voters in India are very large now this time. And the Indian Constitution has granted voting rights to all citizens of sound mind who are above the age of 18 years, irrespective of the individual's caste, religion, social or economic status. So voting is a legal right that is granted to citizens and not a fundamental right. Okay, that is a legal right. In case you are a first-time voter, the registration process must be completed before you vote. For the registration process can be completed online, I told you earlier, and the necessary documents must be uploaded. Given below are some of the rights of the voters that have been granted by the Indian Constitution, like right to know, right not to vote. When you go there and say nota, special assistance to inform and illiterate voters. You have NRI and prisoner voting rights. You have tendered votes. So you can just register as soon as possible. And please note that all Indian citizens are allowed to vote. And very important thing, the following ID cards are required, like Aadhaar card, PAN card if required, and your address proof, and then you can register and do the voting. So definitely I think so as a part of this campaign of Mera Pehla Vote, Desh Ke Naam Pledge, first I will read out in English. You please repeat. All of you now get up and raise your hand. So we are assuming that you are a first time voter in the 2024 election. So I solemnly pledge to actively participate in the electoral process by casting my vote fearlessly and without being influenced by consideration of religion, race, caste, community or language. I acknowledge that every vote matters and commit to making informed decisions based on the issues that affect our communities, nation and the world. I pledge to honor the rich diversity of opinions and perspectives that enrich our national discourse, fostering dialogue, empathy, and understanding in the pursuit of common goals. I pledge to inspire, empower, and mobilize my fellow citizens, igniting a collective flame of civic engagement that illuminates the path towards a brighter tomorrow. I pledge to stand against corruption, injustice, and inequality, using my vote as a tool for positive change. By fulfilling this pledge, I contribute to the strength and vitality of our democracy, ensuring that the voices of all citizens are heard and respected. Now I will read out in Hindi. Kindly please follow it. ठीक है. मैं संकल्प पूर्वक यह घोषणा करता हूँ कि बिना धर्म, जाति, समुदाय या भाषा के प्रभाव में आकर्षित हुए, डर के बिना और विनम्रता से मेरा वोट डालकर चुनावी प्रक्रिया में सक्रिय रूप से भाग लूंगा. मैं स्वीकार करता हूं कि हर वोट मायने रखता है और समुदायों, राष्ट्र और विश्व को प्रभावित करने वाले मुद्दे पर आधारित निर्णय लेने के लिए समर्थ हूं. मैं प्रतिज्ञा लेता हूं कि अपनी राष्ट्रीय बहस को समृद्धि देने वाली विभिन्न रायों और दृष्टिकोण का सम्मान करूंगा. संवाद, सहानुभूति और समझौतों को बढ़ावा दूंगा और सामान्य लक्ष्यों की प्राप्ति से सहायक रहूंगा. मैं अपने सहयोगी नागरिकों को प्रेरित, सशक्त और गतिशील बनाने का संकल्प करता हूं. मैं भ्रष्टाचार, अन्याय और असमानता के खिलाफ खड़े होने का संकल्प करता हूं और अपना वोट सकारात्मक परिवर्तन के लिए उपयोग करूंगा. इस प्रतिज्ञा को पूरा करके मैं हमारे लोकतंत्र की शक्ति और जीवन शक्ति में योगदान देता हूँ. You can sit down. So, in case those who are not attended, please motivate them. Go tell them. The pledge copies are there. You can share with them. It is our right to vote, and I hope you will all participate in the biggest democratic process that is going to be held very soon. So, thank you very much, and thank you all for participating. Thank you.
सेमिनार है सर, अभी कंटिन्यू करेंगे. लास्ट में
As we navigate further into the semiconductor technology, please sit down everybody. As we navigate further into the semiconductor technology, I am delighted to call Associate Professor Dr. Chitrakan Sahu sir from the Department of Electronics and Communication to deliver a presentation on semiconductor technology and scaling trends.
Thank you very much. So I'll not take much time as you have already spent around 2.5 hours. Okay. So just brief 5 minutes. Stay tuned for me. My presentation with
last
video. Okay. So just a 5 minute video about the semiconductor ecosystem. As you know that the Prime Minister has laid foundation for the fabrication plant in India, that is to just build a ecosystem, semiconductor ecosystem for India. So let's understand what is the internationally what is the semiconductor ecosystem is. So just a short video of 5 minutes give a glimpse of what is the ecosystem and how the jobs will be created for especially the young people like you. Okay, so engineer where you can fit. The Verma sir has shown some of the fabrication plants and all those things. Okay, so in the fabrication plants it's mainly for the chemical and mechanical engineer, maybe some electronics engineer for the instrumentation and computation part. Okay, but where the electronics engineers will fit. So this ecosystem will give you an idea the where the jobs will be there for the electronics engineer especially. So I'm
Step further and learning about the semiconductor industry. Like an ecosystem where various creatures live together, in the semiconductor industry, various companies are closely connected to each other in the whole process of design, manufacturing, assembly, testing, and sales. The semiconductor industry is largely divided into three groups. An integrated device manufacturer controls every process from planning to manufacturing the final products on their own. A foundry only oversees manufacturing, and a fabless only has the resources to design semiconductors. A company that takes charge of all processes in producing semiconductors, from planning to producing the final product, is called IDM, or Integrated Device Manufacturer. For example, Samsung Electronics is one of the IDM semiconductor companies. IDM semiconductor companies have production lines and have the means to do everything from designing to producing products. However, there are companies that specialize in design, production, or testing. The first category is a fabless company, which specializes in planning. Fab, or fabrication, refers to the semiconductor production line, and less means the absence of something. In other words, a fabless is a semiconductor company without a production line, which means that it doesn't produce semiconductors. With their knowledge and technology, these companies design semiconductor chips. Hence, companies that produce a wide range of products but in small amounts and keep technological diversity tend to be a fabless. Now, we need a company that is only in charge of manufacturing semiconductors. We call it foundry. A foundry receives a product design from external clients and manufactures the semiconductors. However, a single semiconductor production line is extremely costly, and constant development of process technologies is required. This is why only a few companies have the capacity to do this. A design house is a bridge that connects a fabless and a foundry. It optimizes a fabless company's design so that it is suitable for the production facilities at a foundry. But why does a design house need to convert the semiconductor design to manufacturing purposes? Let's compare it to constructing a building. It starts with an exterior concept design. Based on that, materials used in the building are selected, and the details of the interior and exterior design process follow. Similarly, a design house adds more details to the designs from a fabless, so that the foundry can produce it. In summary, a fabless only designs semiconductors, and a design house optimizes these designs for manufacturing purposes. There are also IP companies. Generally, IP means intellectual property, but in the semiconductor industry, it means something different. IP companies provide specific designs called a cell library to a fabless, IDM, or foundry, and receive licensing fees or royalties on the IP used. In summary, IP companies only sells its design licenses and does not manufacture products of its own brand. Now let's talk about the follow-up processes of semiconductors. An outsourced semiconductor assembly and test company, or OSAT, takes clients in to package and test semiconductors. Basically, it takes care of the back-end processes. OSATs handle testing and packaging semiconductors from foundries. As it is an essential part of expensive electronic gadgets, high reliability is imperative. How come the semiconductor industry is increasingly fragmented? Until the 1980s, there were no distinctions between a fanless and a foundry. The first generation of system semiconductor companies designed and produced by themselves, which led to a high entry barrier. When foundries entered the market and took care of consignment productions, it became an opportunity for many fanless companies to emerge in the industry. Let's review the semiconductor ecosystem. IPs provide semiconductor design blocks. Fanless companies design semiconductors utilizing design blocks from IPs. And using the guides provided by the fanless companies, design houses optimize a fanless company's design to manufacture it. Foundries are in charge of chip production, and OSATs cut wafers into chips, pack, and test the quality of them. With their specialty at each level of the value chain, different types of companies create this ecosystem through division of labor and collaboration.
So what is the answer for this question? Okay, so this is just a brief about semiconductor ecosystem. We required a design house, we required a IP. Okay, just like we have a known the company's name Cadence, right? So Cadence generally.
माइक के पास आ
okay.
जाइएगा.
So Cadence does not fabricate the actual chips, right? They are just for designing. Mentor Graphics, Synopsys, all those are for the designs, and they has their IPs. So we use their libraries like 180 nanometer or 90 nanometer, all those things, right? So this about the brief introduction about that. So I'll just take 2-3 more minutes. Just one slide. I'll not go through whole slide. Okay, just I'll go through that. So this you know that we have the semiconductor is the backbone of all the like wearable devices or automation or 5G or smart cars or smart devices, all required semiconductors, right? So when they started with the computers, the beginning of a computer, that is called the first computer, that is ENIAC, that is the first electronic computer. Okay, these are the some black and white pictures I'm going through. This is the just one transistor BJT and the first integrated circuits 1966, and then we have a processor revolution came 1971, first processor 4004. Then we came into the Pentium processors, right? And then Moore's law continues. We have now i7 processor, Ivy bridge, those things are coming. Okay, so the economics behind the Moore's law was that we are reducing the cost of fabrication by manufacturing plants by using wafer size, increased wafer size. So this is the main, if we are scaling down the transistors, so we are getting high performance, we are getting high frequency of operations and low power consumption. These are the main benefit of the CMOS scaling. So you can understand CMOS scaling by this animations. If you going down for the sizing reduce, the functionality will be same. So if you are moving from 130 nanometer to 32 nanometer technology, what will happen? So see this. So 32 nanometer chips will be equal to CMOS 130 nanometer is equivalent to 1632 nanometer chips. So we can have 16 more operations can be connected at a times. Okay, so this is the technology trends. Is you know that is the complexity of fabrication increases. Many of the companies are going out from the fabrications plants. So currently at 7 nanometer technology we have only 2 foundries that is working, that is Samsung and TSMC. Rest of the them are out from the fabrications. So either they have merged their business with the another companies or moving towards, like as I told, design house. They are working as a design house, not full-time foundries. You might be knowing about various companies like Panasonic, IBM, all those things. Their electronics were coming earlier. Now they are no more coming, especially in the sophisticated design in the nanometer technologies. like 7 nanometers and all. So currently we are using, as you know, that i9 processor is based on the 22 nanometer technologies. So that is the, you can say this picture will clearly shows how the years has been spent from 2001 to 2020 and what are the technological changes has been done, okay, and how the companies trends are going. So they are moving towards more on design. So that's why there is more job opportunities for the you people like in design companies like Mentor Graphics, Cadence, Synopsys is compared to the fabrication, because for the fabrication we need a specialized person for that to handle the instrument. The fabrication people will handle the instrument. If you are able to handle the instrument, then they will hire for you. But for the design one, you need the basic understanding of the VLSI design and microelectronics design, then you will be capable of doing this work in the industry. So the problems is, you know, that CMOS scaling, so I will not go through this that. Okay, so main problem with the scaling earlier was it is driven by the cost, power and efficiency in terms of, but now if we are going further down like 22 nanometer and so on, the more focus on the different kind of materials, different kind of collaborative design process like compound semiconductor and so on. Okay, so the solution to this problem, the solution was to go for a new kind of architecture instead of a CMOS like FinFET designs and all. So Intel has first introduced that 2021 about the transistor, that is tri-gate transistors. Okay, so this is my last slide. It is based on the ITRS production. The new semiconductor devices are coming that is based on nanowire architectures. So that will be the future in coming few days from 20 up to 2028. Okay, so this is the summary. We learned about the basic scaling where every 2 years we chip size changes by 50%. The technology reduce will help us in improving the cost per chip, especially that is very, very important. Okay, and power consumption as well as speed of operations. And despite the many problems, the Intel or any other companies like foundries are managed to produce new kind of architecture like FinFET and silicon nanowire. That's why we are using this in nowadays. Okay. And our India ecosystem will be in line with that. So our foundry that is coming in Gujarat, that is based on the 28 nanometer technology. So we'll be having our own Indian made chips available soon, in maybe in 3-4 years, for our electronic gadgets based on the 28 nanometer technology. Thank you very much for the listening. Thank you.
Thank you, sir, for informative presentation. We are very much thankful to our Honorable Prime Minister for his Vikshit Bharat vision with development of indigenous semiconductor industries. Definitely, this development will be very helpful for our younger generation. We are thankful to our director, sir, for encouraging us for conducting these kind of programs. And also we are thankful to all deans, all head of the department and students for your time and encouragement.
Now everybody stand up for the Jangan.
I kindly request everyone to stand for national anthem.
इसमें है ना है
इसमें नहीं है, मैं पेन ड्राइव लगा दूँ, पेन ड्राइव में है।
जस्ट 1 मिनट बेटा वेट प्लीज अच्छा वो परमिशन ले गए क्या
हाँ
अपना
वो वर्मा सर लेके गए, मैं पेन ड्राइव में लाया था जी जी
शुभ नामे
Thank you very much. Thank you.
Thank